Hello my friends, I just wanted to make this short video to help you do these what we call complex probability problems, and they actually are quite simple once you figure out the pattern, but they're really quite interesting. Okay, so what happens in these problems is there's usually a test. So in this example there's Walmart drug testing their employees. So Walmart has a mandatory drug test. The test attempts to identify users of illegal drugs such as cocaine. Let's assume that the test is 95% accurate. Okay, this means they're explaining what 95% means. This means 95% of the positive test will accurately identify drug user, meaning 5% of the time it'll falsely accuse someone. Okay, so let's assume that 4% of the employees are drug users. Okay, so the test is 95% accurate, and let's assume that 4% of the employees are drug users. What we're going to do is we're going to answer this question right here. If the drug test is positive, what is the probability that the test is wrong and the employee is not using drugs? That is sort of like, suppose you were drug tested at Walmart. You want to be able to figure out, well, what are the odds that I'm actually being falsely accused? Okay, so that turns out to be this probability right here, which is if you're given a test and you test positive, what are the odds that you're not a drug user? Or rather, what's the probability of not being a drug user given that you had a positive test? Okay, so we really are going to sort of imagine that there are 10,000 employees. So this is really like a thought experiment. Suppose there's 10,000 employees. What we do is we're going to use this table to help answer this question. And so we just imagine that there's 10,000 total. Okay, and we assumed that there were 4% of them who were actual drug users. So we're going to take 4% of this 10,000 and write that right here. And that's actually 0.04 times 10,000, right? Right? So I just convert this percentage to a decimal by moving the decimal point 2 places to the left, and then I multiply. And then I get 400 as the total number of drug users. And then you're just subtracting to get the rest of them, because it's 10,000 minus these 400 are the non-drug users. So that's going to be 9,600 non-drug users. Okay, so now the 95% accuracy can help us fill in these up here, which is, okay, so suppose the test is 95% accurate. Suppose the test is 95% accurate. That means that 95% of these 400 drug users are going to test positive because they actually do have the drugs in there. So 0.95 times 400 is, let's see, I'm going to use a calculator to figure that out really quick. I'm going to convert 95% to the decimal 0.95 and then multiply that by 400. And I'm going to get 380. Okay? Now, that means there's 20 people left over. These were all the drug users who lucked out and didn't test positive when they had the drug test. Okay? Now, these are the non-drug users, so really 95% of them are going to test negative. So we're going to do, again, just like we did before, 0.95 times 9600, and we're going to get 0.95 times 9600. We're going to get 9120. And if we subtract that from 9,600, we get 480. Okay? So that leaves us with, it leaves us with 860 total who tested positive. That I just added these two numbers, and then 9,140 who tested negative. Okay. Now, we want to calculate, given that you are one of the people who tested positive, right? So given that you're one of these people, these are all the people who tested positive, what percentage of these people who tested positive were actually not drug users? Okay? So if we go down here to where we want, so we have the people who tested positive. That tells us the denominator. That was 860. Okay? Then we have the people who were non-drug users. That was 480. And so if we take 480 and divide it by the total number of people who tested positive, we get about 56%. Approximately 56%. Wow. That means you have a 56% chance of being falsely accused given that you had a positive test. Great.